So we gave it the title Hydrology and Water Resources Achievements of International Data Centers in Germany. And the background why we have this is that the different hydrological components have traditionally or have a long tradition of being analyzed and measured with conventional data. But over many years now, increasingly, several satellite products are available addressing really all components of the hydrological system, be it precipitation, soil moisture, evaporation, snow, glaciers, ice coverage, sea level, even river level, and estimating runoff, and going on to water quality and also ocean color and growth. So this session aims to provide input on data centers and data available both from the conventional and satellite side. We will first have two presentations on international data centers in Germany, and then this is followed by a discussion of the presenters and also Silvia Puca, looking at various aspects on how these different data sources interact. So we'll start with the presentation of Stephan Dietrich from the Federal Institute of Hydrology, and he's also the Deputy Director of the International Center for Water Resources and Global Change.
Yeah, thank you, Silvia. I think I've presented, you know. So, yeah, also welcome from my side. Yeah, let's start. We have I switched a little bit the title, but I think that is what we're talking about, and I will introduce to what we also call the global terrestrial network of hydrology and the data centers which we are. And already to mark you, I mean, that is also a reason why we are here. We have several celebrations in 2024, and one is what is maybe not so known to you. Since 50 years, Germany is already engaged in the international water programs of the UN organizations, of UNESCO and WMO. We have some data centers like the Global Runoff Data Centers, like the GPCC, working since more than 3 decades for you, for the scientists, but also for reporting to UN organizations and others as well. We come to the data centers later in detail. So, is this working somehow? Next slide, please. It should work, I guess, no? Can you switch the slide, please? Okay, time is running. Can somebody switch the slide, please? That's not, thank you. Oh no, that is. So, but maybe I introduce already the next slide. Now I see the slides here, but not there. So I introduced you already to the next slide. I think it will pop up in a few. The next slide would show you some really news from one report where we contribute to the WMO Global State of the Water Resources report. And on next Monday, there will be the launch of the new report for that. With our data centers, we contribute since the beginning to this important report series. And I would love to show you exclusively, if in before, one of the newest results for that. Now they try to show that. And yeah, so if you're interested to see the full picture, already now I can invite you to join the WMO launch session next Monday at 2 p.m. It's also available online then. I tell you the story, I think, without slides. Maybe that works as well. What would you see in this report is also, let's say, some acceleration of the water cycle. You know? There was a really increase in data delivery to that report. This is the third version of this report. And there's a nice graphic where we show it in normals, in hydrological anomalies somehow. And you see the last year, 2023, was really, if you look at river discharge, the driest year over the last 35 decades, if you compare global river discharges. So, and then we of course, we worked already in combining in situ observations, satellite-derived informations, and of course also modeling exercises to bring all the data together. And 3 weeks ago, and that is one slide which what I would like to, now it's working maybe. Here we go, thank you, technical stuff, very good. So that is now the report, that is what I mentioned. If you look at the hydrological normals, you will really see 2023 is one of the driest years since 1990. And that is a slide which I want to throw you a little bit in the cold water. So if you speak about the water cycle, and if I speak about the water cycle, I mostly personally mean the freshwater domain on the continents. And this was a workshop 2 or 3 weeks ago with Copernicus. So we are already really in a process to bring in situ observations, satellite observations together. But one of the major outcomes was, and that is also what, if you're working in that field, what you know, it is with most in situ observations in Copernicus, but also other applications. The hydrological monitoring is in general not designed and not fit for purpose to be used directly in EO environments. So we're working on that, and with me, and I mean this Global Terrestrial Network of Hydrology. I have the honor to be the coordinator of this circle. It's also already more than 20 years old. It's a joint initiative by GCOS, the Global Climate Observing System, and the WMO. And if you're interested in any kind of in situ observations in the water cycle, please have a look on our web page, gtnh.info, and you will get to that portal and links to the different data centers. 4 of those are operated in Germany. GPCC, Frank Kaspar will explain a little bit more, the Global Runoff Data Center, the International Soil Moisture Network, and the GEMS Water Data Center for Water Quality. Now there's a black screen again. Yeah, sorry for this. Technical issues. It's probably too early in the morning. Those are the data centers. So we have the GRDC, GEMSTAT, and the Global Soil Moisture Center for since 2 years. With all, we can have some celebration this year. Last year it was maybe more the Global Runoff Data Center, but we put it all together. Also, reason why we are here in 1 year. Since 10 years, we have the GEMS Water Data Center, and since 2 years, we are really happy that we convinced the German government to permanent fund this initiative, which was built up by the TU Vienna and funded by ESA money over the more than 10 years. But now it's fully financed for long-term operations. If you also look on the team staff, so the data centers are usually quite small. If you compare it with satellite applications, I think much smaller. 3 team members for the GRDC, 5 team members each for the other both data centers. It's not too much, and the other data centers look similar. We also do have some impact. So we are data infrastructures for the science with quite good publication records, I would say, or usage in publications. We have users from more than 100 countries. We have a lot of downloads, and we directly contribute to UN reportings, like the State of the Global Water Resources reports, like also for implementation and status reports of GCOS. And also one of our data centers directly has developed and provides the monitoring for one of the SDG indicators here for the ambient water quality. This is a paper which we published, and I have seen today and maybe yesterday already some faces here who have contributed to this publication. It's already 3 years old, but this was an exercise to try to, based on observations, can we close the water cycle budget annually on a 5% level. In short, we failed, but it's worth to read because you cannot read it, I think, on the right-hand side, but we also developed some observational needs for in situ and for satellite Earth observations. I think this paper is still relevant to read. Most of the things are still valid over there. So, and that is the area where we are. This is a map from the Global Runoff Data Centers. Red dot means data delivery in a global context. Data exchange is more than 4 decades old. So red dot means last data delivery until mid of 1980s. Blue date means quite up-to-date data. The data are wanted but not shared, and even worse, we have a decline in the capacities worldwide. And that's similar picture for all of the data centers which we have, also in particular spatially. So we have to discuss about some future needs. And what we see here is that the study from Nikos New and colleagues, and they used remote sensing based information to extend the global run of data time series. It's quite nice. So on the map here you see the black are the active stations. We have the inactive stations, so the gray areas here, and blue is now the extension based on EO. I mean, that is kind of the future. It works quite well. I mean, we have some uncertainties in particular in small rivers, but this is a sum of observations which we do have in the global run of data centers. So peak was in the 80s, then since then we have a decline, and with remote sensing you can fill up some of the data. We have also some quality assurance, as mentioned. We have one of our data centers, in situ data centers, which is probably most fit for purpose for used in remote sensing, is International Soil Moisture Network, because it was funded by the ESA and set up by the ESA to fulfill the ground truthing functionality. And they're quite advanced, and there's also the service here, quality assurance service for satellite soil moisture data, where you can compare also your data directly on a web portal within the International Soil Moisture Network, or reanalysis or land surface model data. And last but not least, also water quality is important. If you speak about water resources, it's not only the quantity, the quality matters, and this is one result out of the last data drive. So in this year we collected all the different data from most of the member states to provide this SDG reporting. Not every country reported, not every water body was in that report, and also here to close this gap, EO can help, and there's now a pilot study going on in Africa to develop this. This is my last slide. If you want to engage, please have a look in the WM action plan for hydrology. Most relevant things are here, like improving the interoperability. We really have to combine the complementing features of in situ observations, of satellite observations. And I would ask you one thing, and I think that is what I want to repeat on the panel as well. Please take also care about in situ observations. They are really under stress, as you have seen in the presentations, and we and you need them. And here, with that, I will close. Thanks to my teams, and if you're interested in the State of the Water Global Resources Report, we might see us on Monday. Thank you.
Thanks a lot, Stephan, for this nice overview. And actually, we hope you have questions, but please take a note and keep them for afterwards, because we'll first proceed to the second presentation, and then please feed any questions into the panel discussion later. So the second talk we have is of Frank Kaspar, who is the head of the Hydrological department in the German Weather Service. And he'll speak about decades of climate monitoring and German contributions to water cycle observations. Please.
Okay, I'm not sure. Should I press the green button or? Okay, great. Okay, it has already been explained. So this year the conference is in Germany, and in Germany we host some of the international data centers that have focus on different components of the water cycle. So at DWD we host the Global Precipitation Climatology Center, and also the Satellite Application Facility on Climate Monitoring. Both provide important information for the water cycle, specifically precipitation. And our idea was to provide you some insight into that. I have put the decades of climate monitoring into the title because both data centers have an anniversary this year. So the EUMETSAT CMSAF has its 25th years of operation, and the GPCC started 35 years ago. So both provide information on precipitation. So in case of the GPCC, it's based on in situ data. In case of the CMSAF, it's based on satellite data, and the CMSAF also provides additional parameters that might also be relevant for the assessment of the water cycle. For example, surface radiation is helpful for assessing evapotranspiration and similar elements. So my idea is to give you some insight into these activities. I start with the GPCC. So it is collecting station observations worldwide. So we are in contact with all the national Met services here, and if someone is in the audience who has access to additional station data, we are very happy to receive information on that. But well, we collected data for more than 3 decades now, and so we do the quality control, and at the end we derive gridded products. Well, you see one example here, it's a long-term climatology of precipitation over land. And these gridded products are openly available for climate monitoring and also for scientific research and similar tasks. So here you see a map of the station data that we have. To some extent it looks similar what we have seen from Stephan for the runoff data. So you have some continents where we have very dense networks and also the access to the data so that we can use it. But we have other regions where we have large gaps in the distribution. The colors also indicate the length of the time series. So yellow, for example, indicates that the time series are longer than 100 years. So you also see we receive it from different sources, and you see a change in the density over time. So here also we have a delay in getting access to the data. So you see that at the end of the time series there is a decrease in the number of stations. That is not because the global density of stations has decreased to such an extent, but it takes a while until we receive all the data that we would like to have. So focuses on monthly and daily values. So a number of products are derived from that. So you have some time series that are rather long, starting in 1891, but then we have additional products, for example, with a focus on homogeneity over Europe, or so-called first guess products, which are provided shortly after the end of the month. Well, all these data are publicly available. Yeah, and I will show two use cases now. So this is an analysis of the long-term trends in Europe. So it just has been recently updated. So the data set will be available within the next month. And what you see is an increase in Northern Europe and a decrease in Southern Europe, especially in winter, for example. And an interesting thing is what we see in the data now is consistent to what we have seen in very early climate simulations. So already 30 years ago, it was indicated by climate simulations that we should expect such a pattern over Europe. So now we have a length of the time series that also allows us to evaluate the trends of the simulations. Another recent example was Eastern Europe. So we had this heavy flooding in Eastern Europe, and so the advantage of the GPCC data is that we have the data from different nations, so we can make a transboundary assessment of the precipitation in a water basin. So for example, for the Danube, you see the upper graph with the red line at the end. So in this data set, it was this is a 5-day maximum precipitation. So on that parameter, it was the most extreme event that we have in this time series. So there is a report available, but it's written in German. Okay. I now switch to satellite data. So at DWD, we also host the CMSAF, which is a cooperation in Europe. It's led by DWD, but it's implemented with a number of partners. So there will be a specific precipitation of Rainer Hollmann this afternoon. It's also focusing on 25 years of a sustained generation of satellite-based climate data records by CMSAF. So there you will get insight into all the parameters that are provided by this activity. Here I would like to point to the fact that there is also a recent development of a global precipitation data set. So it's covering land and ocean, and for both land and ocean it's purely based on satellite data. So the previous data sets have had a different approach, for example, combining GPCC over land with satellite data over ocean, but this is a purely satellite-based product recently released. So we come now into the possibility to also make similar assessments as you have seen before, now based on satellite data. I also mentioned that other parameters are provided. For example, surface radiation might be helpful for a full assessment of the water cycle. So there are also long-term products of surface radiation. Of course, it's not only relevant for hydrology, it's also very helpful for renewable energies. So there are tools where the data is used to allow you to specifically select a specific address, and you will get an assessment of the potential for PV production at that site. So all these are freely available. Yeah, just come to the website of both data centers and you will see what we have. And what might also be of interest for like reports similar to what Stephan Dietrich showed, so the so-called anomaly service is in preparation, which will allow to compare the actual situation, for example, the values of the last months with a long-term average. So that will make it easier to get a first impression of the climatological situation. And now we have the advantage that we have 30 years of data, so, or more than 30 years of data, but the data sets are covering a full WMO reference period, so you can compare this with an approach or to refer to this standard interval. Well, that was my last slide. So the message is Germany hosts several data centers with focus on different parameters of the water cycle. And well, we hope that the community will even make more use of that in the future. And we also see that we use satellite and in situ data, so there are advantages for both categories of data. And now I'm happy to discuss.
Yeah, so many thanks, Frank and Stephan again for these nice overviews. Now then we move on to a discussion and then feeding in your questions as well. So I hand over to Paolo for sharing this further, and maybe you introduce also, or I can also introduce, we also welcome Silvia Puca from the Italian Civil Protection Department, and she's the project manager of the Hydrology ZAF of EUMETSAT.
Good morning. Storm Boris brings catastrophic flooding to Central Europe. This is a headline. Unfortunately, behind this headline, there's not only loss of properties, but also still causalities, people lost. So this is, and something that we will hear more and more, because of course we see trends into the extreme part of the statistics of the storms and rainfall in Europe, Central Europe. But I would like to start with Silvia on Boris specifically, and ask Silvia, what are the products that at the civil protection level, in a situation such as Boris, you are trying to put on the table to help the civil protection, and what have been the gaps?
Yeah, so as you said, I work at the civil protection, so I'm first of all a user of these products. And for example, for the Boris events that we have 2 weeks ago, we used, of course, the rain gauges and radar data that we have as ground networks, but in the same time also to have a view of the precipitation and the meteorological events that is coming from other countries. We use the satellite precipitation products. So we have seen that, in particular in Italy, we had a the precipitation products, the satellite precipitation products catch completely the cluster precipitation. So the shape of the precipitation was captured very, very well from satellite data. When I say satellite data in this, I'm thinking about microwave passage and infrared data, so the blending products that we use to have the monitoring of the events every 15 minutes. But in the same time, I have to say that unfortunately, these products didn't catch very well the accuracy. So the amount of precipitation, it was underestimated by the satellite products. So we try to understand why this happened, and we have seen that the main reason was the fact that we didn't have enough passive microwave passage. So what happens is that we had only 3 passive microwave passages, and so the products was able to catch the shape, but not able to really estimate the precipitation very well. And this is what happens when we don't have a microwave passive available, because we cannot estimate precipitation without this data. And this is one of the gaps that we have in Italy, and we have seen also in Europe using HSAF products.
So it seems that, of course, where we move from, let's say, the typical weather prediction usage of user requirement for a microwave, where we move to hydrology, we see that things are changing. So and maybe there's additional data that are certainly needed. And to connect to what Stephan presented, I think it's also what you said. So you are using conventional data, and you are introduced, which is already, I would say, as a very jump into the future, the fact that civil protection uses operationally satellite products. So I'm just a question, what's happening in Germany? How easy it is for the hydrological community to start combining, integrating conventional and satellite data?
Yeah, in Germany, it's also changing, I would say. No, I mean, we had also this year a workshop together with Copernicus, where also different authorities from the different federal states attended, and in Germany, I mean, we have this strong federalism, and the water is in particular dealing with extremes. It's not on the level of the German government, but on the federal state level, and therefore it's important for them. But here we have also really the need in terms of also in Germany capacity building and training. They have to use to learn how to use the new products, the satellite products, and because they're trained to use, let's say, in situ observations. No? They are trained to use first order their observation networks, but they also to manage in the different federal states. So there's also a changing signal. There's a lot of interest in. There's also a lot of capacity which is built up, and I think that's also a role from the Federal Institute of Hydrology to be a connector here, and also to organize such kind of workshops and events to exchange.
And Frank, and maybe also Christina, you are at DWD at the interface between different communities. No, you speak with the hydrology. You interact also, of course, with the climate services type. So how do you see the evolution of these hydrological products from your perspective?
I mean, generally, when we discuss with our German partners, for Germany, they highly trust the in situ based products. But we also see that there is a benefit in combining different data sources. For example, the first step is combining the ground-based measurements with the radar data, but we now have also projects integrating even more data. But in hydrology, we have the situation that, for example, the last event in Eastern Europe, it affected Germany, but the rain came down elsewhere. So, I mean, to completely understand the situation in such an event, we need the data that is also covering other regions. And for example, with in situ data, we still have the problem that we don't have fast access to the data from other regions. So there are a number of topics where we really see advantages in using the combination of data sources. Yeah, maybe you have more to add.
Well, actually, I would like to follow up on that with a question which is linked to this, that data sets, especially the conventional ones, coming from different nations, often have different measurement or calibration standards. Is there an issue in equalizing those or harmonizing those quickly enough? Can there also the integration with satellite data be of help?
Well, I think so. I mean, I have shown one example where we use the homogenized data to analyze the trends in Europe. I mean, these analyses come with a strong delay. So I think there is a gap of several years that are not included. And there has been a lot of effort in homogenizing these data, and we were only able to do it in Europe because there we have a dense network which allows the homogenization. But in other regions it will be much more difficult. So there we will also see a strong advantage in having an alternative data source that we can use in this analysis.
If I cannot, what we have seen, for example, in Italian civil protection is a regional system, so we have civil protection for each regions, that in the last years they really start to use for operational purposes the satellite products. And this was due to the fact, of course, that there were training, but the fact is related also to that you can use together and over a regular grid, different kind of information, not only precipitation, but also soil moisture. And this is a very big impact when you have to forecast the floods. Because we have seen, for example, also with Boris, but also in the Central Europe, that the soil condition was very wet. So the effect of precipitation is completely different. And to have these products, this information together with the same grid is very important for operational purposes. And so they now use, we now use very simple threshold methods that you have the precipitation forecasted together with the soil moisture condition, and together with some threshold you can deliver an alert. And during the events, you can change the level of the alert using the real precipitation. So this is what happens. And so, only to say that the fact that the satellite can provide on the same grid different layers with different information in real time, now it's really appreciated also by operational, I think, agency.
I mean, maybe at this stage we open up, so welcome questions either to what just has been discussed or also relating to the presentations we've seen before.
So the microphone is coming.
Yeah, if you spot one.
It's a very general question to Stephan Dietrich. You said that the water cycle is accelerating. What is the data which allows you to demonstrate that? Which parameters is showing that this is really accelerating, even though we know that water vapor concentration is increasing overall in the atmosphere? How do you measure it from the point of view of hydrology?
Yeah, thanks for the pretty good question, of course. I mean, as we all know, I mean, that was, the signal was also hidden, but nowadays we see it in terms of in precipitation, for instance. I mean, as also Frank has said, I mean, the new observations also allow to validate that what early climate models has already shown several years ago, and we still have, of course, some gaps in the hydrology in the observation system, of course. So we have still some uncertainties. However, all indicators which we measure, I mean, or which we see, are going in that direction, and in particular that we also count an intensification and of the extreme events. So some normal, or the annual average, long-term average data might not change, but the extremes are changing. And that is also not going into both directions. So too less water in droughts and too much water in flood events. And we see both also in a combined event. And all of these combined events are increasing.
Thank you.
Yeah, so there's a question over here. A microphone for this side. I think actually we are a bit blinded here, so please really raise your hands so that we can spot you.
Yeah, thank you. I have a question on Silvia, what you mentioned on the gridding, that providing the information from satellite in the same grid would be beneficial. So a practical question, is there some, well, there are different ways how you grid the data and how you present it. Is there a kind of an established standard in the hydrology community, also maybe at the European level, or in other words, how would you address the difficulties to agree on a common approach on the gridding to really exploit the benefits that you mentioned?
Yeah. No, this is difficult to say. I think that generally I have to say that when the people is in operational environment, they prefer to use the owner, I don't know, platform to visualize and to analyze the data. So it's not common one. So one of the way that we have seen that generally works is the fact that we provide the data, the products in different formats. So they are available, the formats that they more prefer. As you know, for operational purpose, many times we have to add other formats to deliver the products also to other institutes. To have one for European, at European scale, I think that, of course, depends on the application. Because when we say hydrology, in reality, it's many, many different applications. So one of these is very easy. For example, what we do during the monitoring phase, and this is to have a visualization of the product very easy, very quick. And this is very important generally. Another one is to can introduce all these products inside hydrological model. So what is better, to have one hydrological model for at European level, or to have different hydrological model for each country? This is one of topics that are many times discussed in the countries, because it's true that we want to be sure that we are the responsible to provide an alert and so on. And so I think that right now to have only one way, it's very difficult. Also depends if you use this for drought evaluation. So that means that you need also long-term series to have quickly the anomaly evaluation, for example. So we start to work on this with you and other stuff, but still it's difficult to have one way, I think.
So we're just looking if there's
Bojan Łapeta from Poland. I had a comment general concerning the hydrology, but I start with something that would add to what Silvia said already. I mean, you said that the hydrologists, they have a variety of systems and a variety of the models. So the thing that we should remember is that we should provide some kind of flexibility of selecting the period for calculate totals, because it's very specific in every country. So this is the comment to your question. But my general comment from the hydrological point of view and the country that was affected by Boris is that precipitation is very important, but during the situation when the emergency and the crisis appears, it is very important also to provide other parameters that can be derived from the satellite data. I mean, water level information and water extent. And what was shown in this year, that freely available data from Sentinel Copernicus program were not enough to support hydrologists. The timeless is okay, but temporal resolution wasn't enough to provide information about the situation on the ground. So I think we should think about future missions that would provide this very important information to hydrologists, water level and water extent. Thank you.
Yeah. Yes, I'm completely agree with you, Shana. In Italy, during also Boris, we had the possibility to monitor the floods and area affected. So, but it's not enough if we use only Sentinel data. Not only, also if you use optical and SAR. For this reason, for example, in Italy we have a specific satellite constellation, Cosmos SkyMed, and this provides us more than one, sometimes more than one per day. So this is very important because you can understand if the flooding is improved or is still there or is decreasing, and you can also define the actions that you have to do there. So it is a gap that we have now.
There's a question over there. On the meantime that the microphone will reach the far region in the back there, I will ask Stephan maybe a question. So it's important, the connection with Copernicus, how the combination of different satellites, what are new satellite technology that you see relevant as at the moment there's a focus on SWOT as an example. So what's your comment on?
Yeah. I mean, SWOT is in space. There was some delay, as you know. Our first results are promising, which is really good. However, for one full picture, also the SWOT mission only, I think it's every 21 day comes across the gorging station or virtual gorging station and gives an observation point, of course. I mean, GRDC is one of the main data products also deliver for climate purposes monthly data. I mean, there you want the same time frame, of course, but then we have to, of course, to secure this mission for a long time to get climate series out of SWOT. Other aspects are if you need it in particular for early warning systems. I mean, we need some much higher resolution. I mean, that could be, of course, a combination of different satellites in the future. There are some initiatives going on in that direction, which might help here. But until this is solved, I mean, we need in situ observations again, and it's really important to strengthen that, to maintain that, and also to advocate it for decision makers. Not you're a remote sensing community, I know, but not only to invest the money in the satellites, but also in the ground truthing infrastructure, and that is in particular on a global perspective so important. I mean, we have water security issues, we have global migration going on, so we also take care, of course, also to other continents and have a look on that, and that are in particular those areas where we have this data scarcity, and also SWOT will not help in the near future to solve the problems, even if it's a game changer and really help to put the system forward. But to close the gap, there's still something to do.
So thanks. So maybe we first take a question from the audience.
Yeah, it's Li Hangzhou from Nuanestis. Great presentations, and I thought this is really a very a huge potential area to apply the satellite data for hydrology applications. But I think it's critical to not just have more interaction between hydrology community and satellite community, but also cross agencies around the world. Like the HSAF presentation is very informative and seems a lot of great work is being done by German and HSAF. And on the NOAA side, we also have the hydrology initiative that I think led by Dr. Huan Meng, who is also here. And for each of the severe event, like the severe weather events, the team actually put very nice case studies using all different satellite measurements, not just one satellite, but precipitation, soil moisture, vegetation, and other, total pressure water, or other parameters to look the performance and also what's the impact the satellite data can contribute to this kind of events. And it's really important to also understand for different hydrology application, what are the temporal and the spatial resolution needed? Thank you.
Yeah. Important question. Maybe Frank, it calls for CMSAF work.
Yeah, I mean, the first thing that comes to my mind is I talked about the global satellite-based precipitation product, and it is of course based on several satellite system, also on the NOAA system. So, I mean, there is good cooperation in some tasks, but I mean, when you talk specifically about hydrology, I'm not sure. I think certainly you always find something that you can improve, but maybe you have more comments from HSAF side. True?
Yeah. I don't know, because I think that one of the other aspects that you mentioned is the fact it's not easy to try to integrate and try to gather the ground data and the satellite if you want to have a long time series. So this is one of other aspects that we have discussed in the last period. So I don't know if you have tried to do.
I mean, I don't know, Stephan, probably you call for global data sets, and so what?
At the global level, because...
yes, I think there's maybe one initiative which is going on also with the WMO, and this is the expansion of the Global Basic Observing Network now. And the Global Basic Observing Network is that mechanisms to feed the numerical weather prediction services now. That's sometimes for hydrology, it's still a discussion, let's say, because of course hydrologists do not do weather predictions, but we do hydrological predictions, and that's not part of GBON. However, we need some kind of sustainable funding. And related to GBON is a kind of a UN financing mechanism, which is a soft systematic observation financing facility. So we are now working on the expansion of the GBON to hydrological observations, and this is now an ongoing process, let's say, in the WMO world, also to learn from different communities, in particular the modelers, but also from remote sensing, to really understand what are the core parameters, like soil moisture, for instance, no? To really bring that in and to really ask the different member states, please provide observations, because in situ observations of soil moisture, for instance, are not long, so we do not cover climate time series of 30 years of in situ observations, for instance, and we started with that. So the median what we see in our international soil moisture network is around 10 years, let's say. We have to start somehow. We have started, but we have to increase that and really internationally put some effort in it to improve the system.
Thank you. And the in-situ observation is absolutely important for satellite product as well, because one, it can validate the satellite observation, and second, it's important to improve the current algorithm using the in-situ observation to train the algorithms, especially for the AI machine learning kind of algorithm. So it's really important we get very good coverage around the globe of the in-situ observation as well. Thank you.
It's certainly important. We see how relevant is for other value chains, the integration between satellite and the observational system, and how to sustain an observational system which is tailored. It's a critical question because, of course, costs can ramp up in a very. I mean, the greenhouse gas is another example in this different value chain, but it applies. It calls also for probably other application into the hydrology. So as we are interested also to see what are the evolution of user requirements, so the connection between hydrological world and probably the energy sector, or how we start be interested also at the MERT services level to, or at the civil protection level, to monitor water resources, because it's not only the amount of water or the runoff of water, is also what is still available, which is a critical parameter. So in this area, do you have any energy, water resources, anything?
Yeah, I mean, related to renewable energy, one example comes to my mind. So we have a strong increase in renewable energies in Germany and elsewhere, and the government is interested in monitoring the success of this energy transition. So they asked us to provide an assessment, and that includes looking at the weather impact of variability in solar energy, wind, but also on water. So we need the data to provide an assessment of the production of the last year, for example. So, I mean, if you see a strong production in renewable energy, that could be either just by chance because of the variability, or it could be a successful climate policy. And the decision makers want to understand the impact of the weather variability, and therefore high quality data are needed for all the parameters, including the water levels, for example. We also in contact with BFG to discuss how to do that. There we go.
Yeah, also for myself, I mean, two application areas come in my mind. If you speak about water, I mean, we are directly in this nexus discussion, no? I mean, water for what? For whom? No? Is it for energy? If it's for nature, is it for biodiversity? Is it for navigation and river channels? And so we have also, in particular in the data scarcity regions, times, and periods. And also some conflict, and the different communities have to work and to find the best way. For energy, for instance, let's take this example of reservoirs. I mean, water levels, the prediction of water levels, the management of the reservoirs are really important. And but maybe in a kind of a holistic way, because you also have. Let's say if you fill your reservoir for certain purposes, maybe only for energy, and then you might have an issue with too less water downstream, no? Which has conflicts then, or with the food security, that you need also the water for irrigation, that you have influence on your ecosystem downstreams and so on. So that has to be managed together. A second example in terms of emergency, what we see in the Himalayan region is the increase of glacier lake outburst floods. So there's now an increase on observation techniques for flash floods and flooding events, and that is in this mountainous area. It's really, you know, that streams really with maybe centimeters to decimeters water level only in usual conditions, really braided river systems, really broad, and then glacier outburst floods increase, of course, the water level above magnitude. So then we speak about meters of height. And that is, of course, if you build up an early warning system, that's just enough. But if these observations are not usable for any other application area like climate monitoring, no? But because it's so different to calibrate that to discharge then, for instance. And therefore, we have also different observation networks for different kind of applications. And that's tricky sometimes to combine them. I mean, it's a low-hanging fruit, and it really drives, the observation network is really driven by user demands.
Yeah. Maybe we can have another round, whether there's questions from the audience related to this topic.
Hello, can you hear me?
Yeah.
Good. I'm Tobias Borster from SWAN, Netherlands Institute of Space Research. I have a question about isotopic separation of water vapor. So you have a great database, and are you accounting for that? There was also this paper of John Warden showing that the ratio of H2O and water vapor is correlated again with precipitation, and it could add a lot of it. And we provide a scientific data product that basically based on topomy data, and giving you the separation in water vapor and H2O. Could that help to give a broader understanding of the water cycle here?
Yeah, certainly. Interestingly, the isotopes are not an essential climate variable so far. We are working on that, but on the other hand, water isotopes are used in climate application for a long time, also paleoclimate observations. I mean, if you really look on the long time series, but also there are a lot of studies also for, there was a paper this year, I think, in the Alpine area where they use water isotopes to estimate the age of the water, let's say, and then you see what the infiltration time takes and which water resources are, let's say, released to the rivers to causing a flood, if it's direct precipitation or is there some delay. So it's also important for system understanding. In the G10H, which I've introduced, we have 2 data centers by the International Atomic and Energy Agency. It's the CNIP and the CNIRS, the Global Network of Isotopes and Precipitation, and the Global Network of Isotopes and Rivers. And those colleagues do also collect worldwide isotope data, so of the stable water isotopes, for the community to work with that.
Yeah, so thank you very much. I mean, with this, I've just got an eye on the clock. We've nearly reached the end of the session. So our suggestion would be that any further questions and interaction you carry on over coffee. And I'm sure there are also still a few relevant posters around knitting into this topic.
Yeah,
you wanted to add? Of course, yeah.
One comment. Yeah, before we were speaking about to have an idea of the water content that is available, another aspect is very important for drought seasons that we have. And in the last years, we have more than in the past. And for example, we have seen all these more or less in all the Europe, of course, also in Africa. And for example, in Italy, in the south part of Italy, we have seen that the drought season started before than in the previous years. So it started from February, March. That was impressive. And so to have the idea of the water resource is very important. And now it's possible, of course, as we have seen also before, to have the monitoring of the water bodies extent. And we have also a long time series using Sentinel-1, Sentinel-2, other SAR also. And so we can easily to evaluate the anomaly and to understand if our water body extent is less or more than in the past and is changing during the month. And yes, we have this information generally in all the countries, but this is in charge of local authorities. That means they provide in different way, with different frequency, and so it's not so easy to have a complete idea, an idea of complete area that you are interested in the same way. And the satellite products in this moment, so Sentinel-1, Sentinel-2, or Cosmo, other one, really provide you an information that extends every week if you want. And this is a very important tool for the operational purposes and also decision from political point of view, how to manage this resource.
Last word to our estimate guest here.
Maybe only one really last word. If we speak about water resources, we not only speak about water quantity but quality. Please have that in mind. And I think here is a lot of also to do in the future, because that's really increasing the demand of having good overviews of the water quality.
Frank?
Yeah, I agree. I mean, what we have seen when we prepared this event, I mean, there are all these single activities. I mean, even in Germany, we have the data centers, but we did not optimize cooperation, so we do not fully exploit the potential of all these activities. And we are going to do that, but we are open to any cooperation with the community. Maybe
so we hope that this event has been also useful to better connect within Germany. That will be already a very good outcome of this session, and I think we can have applause to our guest here, and you can enjoy the coffee break.